Hello. Today we're going to talk about measurement. So we need to understand that we can use measurement formulas to find the surface area or the volume of solids in 3D space or three-dimensional figures. So before we start this, I want to remind you of two important formulas. We have the midpoint formula and we have the distance formula. Okay, so we know that the midpoint of a 3D figure is going to be equal to x1 plus x2 divided by 2 for the x values, y1 plus y2 divided by 2 for the y values, and we know that it's going to be z1 plus z2 divided by 2 for the z values. We also know that the distance formula of a 3D figure is that the distance is equal to x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So we need to keep these formulas in mind when we work through these questions. So these are the two formulas that you need to write and keep in mind throughout this lesson here. So if we look at our example here, it says a square base pyramid. So they're letting you know that you have a square on your base. A square base pyramid has coordinates 0 or coordinate O, which is located at 0, 0, 0, coordinate A, which is located at 8, 0, 0, coordinate B, which is at 8, 8, 0, coordinate C, which is at 0, 8, 0, and the apex, aka the top of the pyramid, is D, which is located at 4, 4, 10. So it says, verify that the apex lies directly above the center of the base. So whenever I do that, what I need to do is I need to make sure that I look at where the center of the base is. So one thing that we should realize is that the center of the base should lie halfway on the diagonals. So I'm going to first find this midpoint here to see where that center is between A and C. So if I want to find the midpoint between A and C, that is going to be equal to, and once again, use the midpoint formula here. So we're going to use this formula, okay, using this formula, we are going to plug it in. So that's going to be 8 plus 0 for the x's divided by 2. So that's going to be 8 divided by 2 for the x's. If we add the y values, that's going to be 0 plus 8, which is 8. Divide that by 2. If we add the y's, that's 0 plus 0, which is 0, divided by 2. So if we simplify it, that's going to be 4, 4, 0. So that is where that blue dot is. It is at 4, 4, 0. Okay. So the next part that I want to look at is I want to look and see if I look at the other diagonal, if I get the same point. So my other diagonal is occurring between the origin and point B. So that's OB. So when I find the midpoint between OB, I'm going to do the same thing, except I'm dealing with 0, 0, 0 and 8, 8, 0. So when I add the x's, I get 8. And of course, I got to divide by 2. When I add the y values between O and B, I get 8 divided by 2. And when I add the z values, that's going to be 0 divided by 2, which gives me the same point, which is at 4, 4, 0. So I can see that that is my center. They both overlap there. So because I know that that is my center, I can now label this point, and I'm going to label it as 440. So now what I need to do is in order to tell if this point lies directly, if the apex D lies directly above that center point, I need to pay attention to how everything is written. My X's and my Y's are both 4s. The main thing that is different is the Y values going from 0 to 10. So I can tell here that from 0 to 10 is going to be my height of the pyramid. So when it says, does it lie directly above the center of the base? The answer is yes, because the Z values are different. Everything else is the same. So that means that they're only placed above and below each other. All right, so the next thing we want to do is we want to find the volume of the pyramid. So the volume of this pyramid is equal to 1/3 times the area of the base, which this is a square. So this is going to be the side times the side, which is the side squared, that's the area, times the height. So all I have to do here is substitute in. So I'm going to get V is equal to 1/3. And if we look here, we already can tell that the length of our square here from 0 to 800, the length is 8, and from 000 to C, which is located at 080, that length is 8. So we know that we have a square. So we have to substitute in 8 for the length, and then we have to substitute in the height of the pyramid. And the height of the pyramid, remember, is referring to going from the top of the apex down. Okay, so that is my height, and I know that my height here is 10. So when I multiply it by the 10, I'm going to have 1/3 times 8 squared times 10, and then I can turn it into a decimal, and then I end up getting that this is around 213 units squared, or excuse me, units cubed, because it's volume. All right, so that is my answer here. So the next part that I need to do is I need to now look at part C. Part C says, suppose M is the midpoint of BC. Okay, M is the midpoint of BC. Find the coordinates of M. So it's telling you that M is the midpoint. Okay, I'm going to erase a lot of this stuff here because I don't necessarily need it right now. So if I say that M is the midpoint of BC, I am referring to this point here. And because I say it's the midpoint between B and C, it is halfway in between. So if I want to actually find the coordinates of M, I know all I have to do is find the midpoints. So I need to add my X values. So that's going to be 8 divided by 2. Add my Y values, which is going to be 16 divided by 2. And then add my Z values, which is going to be 0 divided by 2. So when I do that, I simplify it. I get 480. So that is my midpoint there. So of course, when I get it, I'm going to write it in. So that's going to be 480. Okay, 480. So that is going to be that point, and I wrote it in. So now it says find the exact length between M and D. So I want to go between M to D here. So I want to find out how long that is. So what I'm now going to do is I'm going to use the distance formula to find that green line here. And let me use a slightly different color so that it won't be hard for you to see. Okay, so I'm going to use the brown line. So if I want to find that brown line, or the length of that brown line, I just use the distance formula. So my distance is equal to the square root of, and I just subtract my x value, so that's going to be 4 minus 4 squared plus, that's going to be the y values, 4 minus 8 squared plus the z values, which is going to be 10 minus 0 squared. So when I put that into the calculator, please make sure you are careful at what you type in, because one wrong thing can throw everything off. So when I do that, I will end up getting approximately that this is 10.8 units. All right, because that is my length. So now that I have this 10.8 units, I can then go down and I can find the surface area. Remember, your surface area is nothing but the area of all of your surfaces. So you have this square pyramid. So you have 5 surfaces. You have here, you have a square. You also have the triangles that's going around it. So we already know that the area of the square is just going to be equal to, we know the square is 8 units long. So we know that the area of the square is going to be 8 times 8, which is 8 squared, which is equal to 64. The area of the triangle, even though we have 4 of them, focus on one of them at a time, is going to be equal to 1/2 times the base. The base of the triangle, and when I say the triangle, I'm referring to the one on the side here. The base of this triangle is going to be the length of that square. So that is going to be 1/2 times 8 times the height of that triangle. The height of that triangle is the 10.8 units. So if we substitute that in, we're going to have 1/2 times 8 times 10.8, and that will give us 43.2. And we know that that's units squared. So now in order to find the surface area, we have to add the area of the square, which is the 64, and then we have to add 43.2 4 times, or just do 4 times 43.2, because that is the area for that triangle, and we have 4 of them. So 64 plus 4 times 43.2, that is 236.8, and we know that that is units squared, because once again, that is area. All right, so that's how we find our surface area. Our last problem, while we're talking about trigonometry, we also need to realize that we can use trigonometry to find measurements of 3D figures as well. So it says here, find the angle between segment AG. So if I draw on my line to go from A to G, okay, I want to figure out how long that is, okay? I want to figure out the angle that segment AG is going to make with the base plane ABCO. So that means if I start at A and I go to B and I go to C, I go back to O and I come back, that is the base plane, which technically means that I want to see if I were to take the line segment from A to G, and if I was to literally just drop the part, if I were to drop G down, it will touch here. So that means that I need to match that up with this diagonal here. Okay, so, and you will see that when I drew that diagonal, you should see that it now created a right triangle here. All right, so let's look here. Before I can do any calculations, I need to actually figure out what these points are. So let me see if I can look at the location for G. So as you can see, G is literally on the same back side as D. So that means the X values are going to be the same, 0. The y value of G is going to be the same y value as C because it's on top of it. So that means that the y value is going to be 8, and the Z value is going to be the same as point D because it's on the same level up top. So that is the point for G. If I look at those points here, I need to figure out, and actually I can use this to figure out my height. So if I'm looking at G to C, I can tell that G and C are the exact same because the 0 and the 8 are the same. The only thing that's different is the Z values. So I know that this is 6 units tall. So now what I want to do is I want to figure out what AG is. How long is AG? So I'm going to use the distance formula. So I'm going to have 10 minus 0 squared plus 0 minus 0 squared plus, or excuse me, let me go back. I'm looking at the wrong point. That would be 10 minus 0 squared plus 0 minus 8 squared plus 0 minus 6 squared. All right. So that will be the length there. All right. And all I have to do, once again, is put it in the calculator. Make sure that I'm neat with what I type in. So 10 minus 0 squared plus 0 minus 8 squared plus 0 minus 6 squared. All right. So once I plug that in, then I see that we end up getting that AG is approximately 14.1 units. So because I know that, I'm going to write that in on the picture. So that's 14.1. All right. So now that I know that that is 14.1, I can write it in. And now I can figure out the angle that it makes with the base plane or the bottom. The angle that it makes with the base plane is here. So this will be the angle theta that I want to find. In relation to this angle, you have the opposite and you have the hypotenuse. Hypotenuse is always across from the 90. So if I were to write this, opposite of hypotenuse is sine. So that will be sine of theta is equal to 6 over 14.1. All right. So if I take the inverse, I know that theta is going to be equal to the sine inverse of 6 over 14.1. So if I do sine inverse, and make sure that your calculator is in degree mode. So if I do sine inverse of 6 over 14.1, I will end up getting that my theta, or my angle, is approximately 25.2 degrees in 3 significant figures. So the line segment AG makes a 25.2 degree angle with the bottom of that 3-dimensional figure. All right, so if you have any questions, please ask your teacher, and have a great day.